All right, guys, welcome back. So we have successfully made it to Unit 3. Well, hopefully successfully. If not, please do ask me questions, right? Just because I'm moving on in terms of the lessons in these videos doesn't mean you can't still come talk to me to clarify things you didn't understand in the past. Anything I would encourage you to, because as I've said in the past, this course builds on itself. So if you didn't understand something from lesson 1 or 2, it's going to kind of continue on to lesson 3, 4, 5, 6, 7. And we definitely don't want that. Okay, but lesson 3, and what are we going to do first? You're right. Write our name. So me, Mr. B, or Berube. With the accents and everything. Okay, let's get into it. So lesson 1 is going to basically be a bit of a introduction to polynomials. So some of you are like, I kind of maybe know what a polynomial is. A few of you are like, I think I heard somebody talk about that on a game show, or polynomials, isn't that like a shape or something like that, right? Doesn't matter. I got you covered. We're going to take care of this one thing at a time. Okay. So let's just read out what's here, and then I'm going to help you guys through with the definitions, give you some examples. We'll use some of those definitions and examples, and then we're more or less done in lesson 1. Awesome. So math comes with its own language. The language of math is universal and can be understood anywhere in the world, and this is true. The explanations might be in a different language, but in the numbers, the equations, that is used across all languages, okay? And so in this unit, we will explore the language of algebra, okay? So you've definitely heard of algebra before, I'm sure, and you've already used it, whether you even realize it or not, okay? So algebra is a branch of mathematics that uses symbols to represent unknown numbers or quantities, okay? And so you've probably done like 3 plus question mark equals 4, and you're all like, oh, the question mark equals 1, so then it's 3 plus 1 equals 4. You just did algebra. Congratulations. Okay, but that's not what we're going to focus on anymore, because that's something I think we can do from the time we start to add almost. Okay, so let's look at some definitions, and then from there we'll be able to use those definitions. Okay, so a polynomial is one term or the sum of terms that make up the numbers and variables. Okay, so one example of that could be something like 3x squared, right? So we're using symbols. X is a symbol in this case, plus x 8. Okay, so in this example here, we have more than one term or the sum of. So here's one term and here's another term, and so a sum is an addition. That make up the numbers and variables. So we've got some numbers, we've got some variables, and we'll talk about what all of those different pieces are when we're looking at algebra. Okay, terms. So terms are a number, a variable, so the letter, or a number with a variable. Okay, so we talked about one term or more, and so now what is a term? Well, usually these are also separated by plus or minus, right? Addition or subtraction, okay? So one example could be here like 3x squared again, right? Plus 8x has 2 terms because there is a number and a variable, okay? Or a number with a variable together, right? So it can just be x squared if we wanted. Could just be x, could be 3x squared, it doesn't really matter. But those are all each individually terms in our polynomial. Okay? A variable is a letter that represents a number that can change, right? So we do this in math a lot because we don't always know all the information, but we can use the information we do know to solve something we don't know, right? So those could be like the letter x, n, L, right? We usually do like cursive L's because just a normal L looks kind of like a 1, depending how you draw your ones, right? Could be the letter Y, could be the letter P, okay? We try not to do like the letter O for the same reason. and it looks like a 0. And there's a few other letters that sometimes can be a little confusing, but again, technically any letter or could be used. Okay, a coefficient is a number directly in front of a variable. So these are variables. A coefficient always comes right before. So here, if we had 7, n, the 7 is our coefficient because it comes directly before our variable, in this case n. Monomials are a polynomial with one term, okay? So here 6x squared, okay? There's just one term. There's no additions or subtractions in between. A binomial is 2 terms, so we can do 3a squared minus 5, right? Could be one example. We could also have 2b plus 7a squared minus 4, and that would be a trinomial because we have 3 terms, right? 1, 2, and there's a subtraction here, so 4. Okay, a constant is a number by itself. So in this case, we could say 13, right? It's just the number 13. It's constant. It doesn't change because we don't have a variable. So the variables are the only things that can change. A constant does not change. You learned that back in grade 6, and I know that because I taught grade 6 now. All right, and the last thing is a degree. Okay, so a degree is the value of the greatest. Okay, that's the most important part, the greatest exponent of a term or a polynomial. So in this case here, we have 3x squared plus 8x. You can even say to the power of 1 if you wanted, right? And this has degree of 2. Because 2 is the biggest exponent, right? 2 is bigger than 1, so ta-da. Okay. All right, so that's the main part of our definitions. Now let's move into how do we actually use this. So, for each expression, identify the number of terms and whether it is a monomial, polynomial, binomial, trinomial, or a constant. Okay, so we're going to kind of break it down to a lot of options. So, for number 1 here, we have 4xy plus 3, right? And 4xy means 4 times x times y. It's not 4 times y, like the x is the variable. So here, how many terms do we have? Well, 1, 2, okay? Even though this is a constant, it counts as a term. It doesn't always have to have a variable. So here we would say 2 terms and then here we have a binomial, right? Because there's 2 terms. Binomial. Okay, over here we have 3 terms, right? 1, 2, 3. And so that makes this a trinomial. Here we have 1, 2, 3, 4, 5 terms. Wow. And so we would simply call that a polynomial. All of these are polynomials, but for 1, 2, and 3 term polynomials, we have specific names for them. Anything after that, we just get lazy and bored and tired of calling them, so we just call it a polynomial. Okay, and lastly here we have 1 term, and that is referred to as a constant. Okay, we're going to take a little time out here and we'll get back to it. Jazz hands. All right, so we're going to continue with example 2. Okay, and so this is where we're going to talk about our degree. So first, what is the number of terms? Same as before. Here we have 2 terms. And we're also trying to figure out the degree. So how do we remember to find a degree? Well, we look at the highest exponent. Okay, here we have an exponent that's to the power of 2, and then over here, nothing. So obviously 2 trumps nothing. So degree is 2. Okay. For this next example here, we have 1, 2, 3 terms. And the degree is 1. Okay, and this last one, right, there's one term, and so there's no exponent, so we would say degree is 0, okay? And that's how we do that. So this one and example 1 should be pretty straightforward. It's mostly just counting and then naming things. So it's just using our definitions, okay? Modeling polynomials with algebra tiles. I know you learned this in grade 7 or 8, but we're definitely going to recap it because I'm sure it's been a little while, and so we want to make sure you understand it because you will definitely be expected to know it, okay? So when we use algebra tiles, doesn't matter if it's black or red or blue or whatever, as long as you are consistent, or if it's given to you, then you use the example that was given. So here we're going to say the red tiles or the colored in tiles are going to be positive. So this would be representative of an x squared. This would be an x, and this would be a single unit, 1. Okay. Over here, we would have negative x squared, negative x, and negative 1. Okay. So this is kind of our legend. This is going to help us represent, okay, our polynomials using algebra tiles. Okay, and that's a good skill, especially because sometimes we need to know how to visualize things. And we'll see how, especially when we're multiplying them together, this could be helpful. Okay, so what we're going to do is represent 3x squared minus x plus 2 using algebra tiles. Okay, so we don't have a lot of room to do it here, so I'm going to do it on the next page. Okay, so we have 3x squared, so I need 3x squareds, right? I have minus 2, or minus x, sorry. So I have 1 stick, that's kind of how what I like to call them, and it's not colored in because it's a negative, right? And then plus 2. Let me just quickly color these in, okay? So if you were doing this on your own, right, you would just scribble. You don't have to color in every little bit of the tile. That's very time consuming. And let's be honest, I don't care if you have perfect color in the line skills. Maybe Miss Atkinson does with art, and you'll find out more about that next semester. Okay, so let's continue on to the next. Okay. Represent negative 4x squared plus 6x minus 1 using algebra tiles. So we're going to do the exact same thing that we just did. Negative x squareds are represented by big blank squares. Okay. Plus 6x, we said those are sticks, and they've been colored in. So 2, 3, 4, 5, 6. So although I don't care if they're perfectly colored in, one thing I do care is that they make sense of how they're ordered. I don't want half of these sticks here, half of them there. It's not a scavenger hunt. If I can't simply find your answer, I'm just going to mark it wrong because my time is as valuable as yours. Okay? And minus 1 is a small blank square. Awesome. Problem solved. Done. No worries. Okay, so note that when combining like terms using algebra tiles, 2 tiles of the opposite sign cancel out and become 0. So here we had a positive and a negative, right? So they cancel out, and we're left with 0 or nothing. Okay, so we're going to use that to help us answer the last part of this first lesson. Okay. Oh, actually, I lied, but I'm going to show you one more example. So say we have 3x squared minus x squared equals 1, right? So we can draw this out, okay? So we have 3x squared And they're colored in because they're positives. Right? And then we have minus x squared. So we just draw our minus x squared, okay? So we have 3 positives, 1 negative. The positives and the negatives in the same numbers cancel out, right? And all I'm left with is 2 positives. So then my answer would be 2x squared, right? So this is a good way of visualizing how do our terms cancel out. It's a little more time consuming because we're drawing it, but it is a skill that we should have. Okay, that's all I have for lesson 1. Your homework is going to be found in the textbook, page 179, questions 5 to 14. Good luck, and if you have any questions, come see me.